Hello, Algebra 2 students. Glad you found some time to get your notes taken care of. I hope you're well. Today we are going to be looking a little bit deeper into the graphing of the square root functions, so please copy down your title as well as your objective. And the objective is the student will learn the graphing procedures for square root functions. As always, press pause anytime you need more time to get notes taken care of, and then hit play when you're ready to move forward. Let's begin. Now, last time we were looking at the basic parameter changes that were involved with the square root function. And hopefully most of them weren't a big surprise to you, because most of the parameter changes worked exactly the same as the parameter changes did with the parabolas. In fact, you will find that to be kind of a commonality as we move through this entire semester. A lot of the functions that we're going to be looking at, okay, the h comma k and all that kind of stuff, that's going to be the way that's going to be the way a lot of them are going to be built. Okay, so but what we looked at yesterday was we were learning to read the equations. Okay, learning to read the numbers out of the equation, learning to read the signs out of the equation in order to tell us what to expect about the graphs. So as I have there, in short, we made the equations tell us about the graphs. Today we're going to be looking at more in depth at getting the functions precisely graphed where they belong. So not just necessarily just knowing, does it go up or does it go down, or does it go left or does it go right, and that kind of stuff, but with what speed does it move upward or downward, and things of this nature. Okay, so that's going to mean having a little bit better understanding of the equation. Okay, and the key to graphing these is understanding how the parent function moves through the graph, and then adjusting everything else from there. Okay, now we're actually going to employ a technique for getting this graphing done that is kind of like kind of old school, for lack of a better way of putting it. Back in the day, the very first graphing technique that you most likely learned was the method of plotting. In other words, figuring out where coordinates were, and if you could simply plot enough points, then it became a connect the dot puzzle, and all you had to do was just connect all the points that you had in the graph, and that ended up being a representative of what it was you were graphing. Okay, well, you're going to find out that the higher you go in math, actually that is a very effective graphing technique, especially if you are uncertain of how a graph is going to behave inside of the graph. Okay, so the plotting method is going to be the deal. Now, here is the parent square root function, y equals the square root of x. Now, what we're going to do is we are going to explore some points. Now, back in the day when you did the plotting method, we were working on very simple type graphs, things like lines and stuff like that, where they were very predictable. So once you knew 2 or 3 points on a graph, you knew pretty much what the entire graph was going to do. Okay, however, we're dealing with some graphs that are a little bit more unpredictable. They can change directions, they can change speeds that they're moving. Okay, so we're going to need more than 2 or 3 points. So my suggestion to you is when you do the plotting method, or my expectation rather would be a better way of saying it, is that we are going to graph a minimum, or we're going to check on a minimum of 9 points. Okay, now the easiest way, or the best location to do this, is to start off at infinity, or at 0, pardon me. Okay, and then take 4 whole steps in each direction away from the origin. So like I have here in this little XYT chart, is I have from -4 all the way up to +4 in whole steps. Okay, now this is typically the way we do it. We usually invent values in the domain to plug in. Now, as you're going to see, it's not always the domain values that we're going to be picking. Particularly what we're doing is we are picking values that are going to be underneath the square root. In this case, it just so happens that that variable is the x value in this case. So we're picking values to plug in underneath the square root to see what happens, in this case, to the y values. Okay, so based upon these values that we have just invented on either side of the origin, when we plug them in one at a time, what we see is, of course, these values are going in underneath that radical. So when x is -4, the y value is whatever the result of the square root of -4 is. When x is -3, y is the square root of -3. When x is -2, y is the square root of -2, and so on. Now, clearly, some of these values will simplify into easier forms. Some of these values will not simplify into easier forms, and we're going to end up with some irrational numbers, meaning we're going to get some crazy decimal points. Okay, and some of these values will not simplify at all, or at least not in a way that we can put them in a graph. So taking the next step and looking at what these y values actually mean, what we see is, of course, that we've got some imaginary numbers. Now, we know how to deal with the imaginary numbers, but we're not going to, because imaginary numbers cannot show up in our graphs. We cannot go somewhere and say, hey, here is an imaginary spot. So we have negative numbers underneath our radicals. Those will be values that we will disregard. Now, some of these at the bottom simplified. The square root of 0 was 0, the square root of 1 was 1, and the square root of 4 was 2. Now, the square root of 2 and the square root of 3 are irrational numbers. So I got some approximation decimal points there, and that's what the little double wiggle there is called, approximately equal to. Looks like an equal sign, just wavy. Okay, means approximately equal to. We need to know what those values are, because here in a moment we're going to be putting them in a graph, and we need to know exactly how far in between certain whole numbers these decimal points are. Okay, so taking that same information, okay, just turning the page and I'm putting a graph in place. As we said, we're going to disregard the imaginary numbers. They have no place in the Cartesian coordinate system. Okay. The other ones, however, the ones that have the little yellow dots next to them, they have locations. So we're going to go to those locations and we're going to plot some points. So we're going to have a point at 0, 0. We're going to have a point at 1, 1, a point at 2, 1.41, 3, 1.73, and 4, 2. Okay, so when you plot those points in the graph, you simply connect the dots, and there is the parent square root function. Okay, now let's take a look at another equation and see how it may change if the equation gets more complicated. Okay, the note there says the same holds true even if the equation is more detailed. Now, once again, we're looking at an equation that says y equals, and then something to do with the square root of x. So once again, our graph is going to turn horizontally and run to infinity horizontally. Okay, but of course, keep in mind, the equation could be inversed. It could say x equals y, something to do with the square root of y. Okay, so we are picking x values again because x is the value that is underneath the radical. If it had been a y underneath there, we would currently be putting values in the y column and then plugging in to find out what goes on with x. Okay, but once again, we're going to pick several values. Okay, and again, I take the origin and then 4 steps on either side of the origin. And what you're going to find is that sometimes even that may not be enough points to get a good idea of the graph. You may have to pick more than even that. Okay, but we're going to start with these and see if they're good enough. So if we take these x values and plug them into the function one at a time, they're going to give us these values. When -4 goes underneath the radical, that's going to result in -2 underneath the radical, and then -4 is hanging on to the outside. When -3 goes in, that gives us -1 underneath the radical, -4, and so on. Now, once again, some of these values are going to be disregarded, some of them are going to be simplified, and some of them we're going to have to figure out what the decimal point approximations are. Okay, and in this case, we are going to end up with a couple of points on x equals -4 and x equals -3 that are imaginary because of the negative under the radical, so we will disregard those. Okay, We see that from there on out, some of them simplify to whole numbers, and some of them simplify to irrational decimal points. And again, irrational means the decimal point does not ever stop, and it does not ever repeat. Okay, so we end up having to round it off just to manage it. Okay, so using these values, once again, it looks like in this case we're going to have 7 points that we're going to be able to plot. There'll be one at 2, -2, one at 1, -3, and so on. So taking this information to a graph, again, we're going to disregard the imaginary results, but we're going to have 7 points, the ones with the little yellow dots next to them. Those 7 points are going to get graphed, and those locations would look like this, and there is your graph. Now, of course, keep in mind, there's a lot of changes that can be made to these equations. We can turn these graphs upside down. We can turn them backwards, left to right. We can speed them up and slow them down by changing different coefficients and values all over the place. And you will see many of those type problems, okay, with those values change. But it does not change the concept. You pick your values of the variable that's underneath the radical. You pick values for that variable. You plug them in and find out what is the corresponding value for the other variable. Then you can graph and connect the dots, and you're done. Okay, I would like you to take one more example here. I want you to plug in values for this variable, or this equation. Once again, it will be x's that we are plugging in because x is the variable underneath the radical. Okay, I want you to plug these 9 values in, or at least these 9 values in, and let's see if that's enough information to get a good idea of the graph. Okay, get you the y values that go with these x values, draw yourself a graph, bring that with you when you come to class. I appreciate you getting time to get your notes done, and I will see you in class. I'll leave the video running for a few more seconds if you need more time to copy this down, but the audio ends now.